Okay, students, Miss Whitaker here again, and I'm going to talk about dividing fractions today. And I know you're probably thinking, oh, fractions again, but I'm so excited about teaching dividing to you, trying it a little bit different way this year, and I hope it makes some sense to you, and I hope it's going to be easy for you. Now, when we talked about multiplying fractions, we were talking about part of a part or a fraction of something. So maybe sometimes a fraction of a fraction. So we would just multiply the tops, multiply the bottoms, and reduce. Also, when we were doing adding and subtracting fractions, we wanted to match up equivalent fractions that had the same denominators. We couldn't add apples to oranges or oranges to apples. We had to make them the same thing before we could combine or take away, so that we had to have the same parts. When we're talking about dividing fractions, we also want to have the same parts. So I'm going to put up some possible dividing of fractions problems up here for you first of all, and we want to talk about how can we divide 8 by 4/5. And basically what that's saying is how many 4/5 are there in 8. Now when I'm multiplying or dividing fractions, I do want to go ahead and put my whole numbers over 1 so they look kind of similar. So I have now 8 over 1 divided by 4/5. All right, now what I want to do is get common denominators. So let's figure out what that is. We got to find a common multiple for the 1 and the 5. And that's just going to be 1 times 5. So that's just going to be 5. So let's find our common denominators and get our equivalent fractions. This one didn't change, so we're going to keep that as a 4. But this one did change. From 1 to the 5, I multiplied by 5, so I'm going to have to do 8 times 5 to get my new numerator. Because what I'm basically saying is that 8 over 1 is the same thing, or is equivalent to 40 over 5. And I needed to get that 40 over 5 so I could have equivalent fractions here with my fifths. Now, when I'm dividing, all I'm doing now, if I have the same denominator, all I need to do now is divide the numerators. 40 divided by 4, which is 10. And that's going to be my answer. My question basically turned into how many 4/5 were there in 40/5. Well, there would be 10 of those 4/5. If I put 40/5 along a straight line here, and I'm just going to roughly, if I broke this down into fifths, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, I think that's 30, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's 40/5. How many 4/5 would there be in that? So I've got, there's 1, and then here's 2, and I just keep going, keep going. I'm going to have 10 of those in there. So a little bit different way of doing it this year, but we're going to try it. So let's try another example. Now remember, when we have equal parts, when our denominators are the same, then it's just a matter of dividing the numerators. So basically, here's our rule. To divide fractions, the denominators must be the same, and the answer will be the quotient or the division answer of the numerators only. So let's try another example. Let's do 5/9 divided by 1/8. All right, first of all, let's get our common denominators so I can divide with equal parts. I don't have to worry about the parts being different. Oh, 9 and 8. I wonder if you could think of what the common denominator is for 9 and 8. Well, it's going to be, actually turns out to be 72 when you multiply 9 and 8. There's not one any lower than that. So our denominator becomes 72. This is still a division problem. If I change the denominator, then I've got to change the numerator because we're talking about equivalent fractions like we talked about with adding and subtracting. So I could list all my equivalent fractions to 5/9, but I'm just going to say 9 to 72 was times 8. So 5 times 8 is going to give me my new numerator. So 40 over 72 is the same thing as 5/9. Now I'm going to do the same thing with 8 to 72 was times 9. So 1 times 9 is going to give me 9. And now my answer to my problem of how many 1/8 are there in 5/9, and now it turned into how many 9/72 is there in 40/72, then I'm just going to end up taking my numerators and dividing 40 divided by 9, which turns into, how many times will 9 go into 40? 4 times, with 4 left over, and I'm still talking about 9ths. So let's do one more example, and I'm going to make this a little bit harder, taking a lesson what we learned when we were multiplying. All right, so now I've got 2.5, throwing in some mixed numbers here, and I'm going to divide by 3 1/7. Okay, now we're going to have to, first of all, change these mixed numbers to improper. So I'm just dealing with fractional parts. All right, so 2 times 2 plus 1 is 5/2. And then 7 times 3 is 21, plus 1 is 22/7. All right, now I'm going to have to get my common denominator, so let's do that. So we have equal parts on both fractions. Now it's going to be 14. So I'm going to change those, and if I change my denominators, I'm going to have to change the numerators to make them equivalent. So 2 to 14 was times 7, so 5 times 7 is going to be 35. And I'm dividing, and then 7 to 14 was times 2, so 22 times 2 is 44. So then I end up, since my parts are the same, I end up just taking my numerators and dividing 35 divided by 44, and that actually turns out to be my answer. It is a proper fraction, so I don't need to change it to a mix, and it cannot be reduced, so that's my answer. All right, so we're going to do a little bit of practice with this, and hope that dividing fractions makes a little bit more sense to you, and please feel free to email me if you have any questions. Bye for now.